mole of an ideal gas. So 1 mole of an ideal gas means N equals to 1 is compressed isothermally. So it is compressed isothermally. So this is isothermal compression. And remember, if isothermal means it is constant temperature. Constant temperature. So from 4V to V. So this is the volume. The initial volume is 4V and the final volume is V. And the work done on the gas, is 4.5 times 10 to the power of 3 joule. So this is the work done. So the first question asks us to sketch a PV graph for this process. And remember, this process is isothermal compression because it is compressed. So we have PV graph, and please label your unit. This is Pascal, whereas this is meter cube. So because this is isothermal compression, means it is compressed. So when it is compressed, the volume will decrease, whereas the pressure will increase because pressure is inversely proportional to volume. So when your volume is decreased, your pressure is increased. So this is how you sketch your graph. Okay, B. Calculate the heat transferred during this compression. So we need to calculate the heat transferred during this compression. And is the heat absorbed or released by the system? Okay, let's do it. So how are we going to tackle this question? First of all, we know Q equals to change in internal energy plus work done. And remember, for isothermal, it is constant temperature. Constant temperature. When it is constant temperature, your change in internal energy is 0. So therefore, Q equals to work done. And your work done is 4.5 times 10 to the power of 3 joule. So this is your work done. Okay, I will write like this so that you can understand. 4.5 times 10 to the power of 3 joule. But read the sentence properly. Work done on the gas. So work done on the system. If the work done on the system, it will be negative. Therefore, heat transferred is negative 4.5 times 10 to the power of 3 joule. So that's for question B. Okay, let's proceed with question C. Calculate the isothermal process temperature. So it asks us to calculate the process for isothermal temperature. So we already know our work done. So from work done, actually we can calculate our temperature because work done equals to nRT ln V2 over V1. Final volume over initial volume. And we know the work done is negative 4.5 times 10 to the power of 3. And the number of mole is 1. And the molar gas constant is 8.31. And we are going to look for the temperature and ln, and final volume is V, whereas the initial volume is 4V because it is compressed. So when it is compressed, means the volume is decreasing. Okay, the volume is decreasing. So the initial volume is 4V, whereas the initial volume is 4V, whereas the final volume is V. So rearrange this equation and press your calculator. You will get your temperature 390.62 Kelvin.